seems to have having a few glitches, but we'll try it. So we're now in, you guys have gotten some ideas about some of these tools, you've gotten pieces. I want to go in and look and remind you of where a couple of things live, and also we're going to pull up a document. And you are welcome to do this in Blackboard at the same time. So if I look over here in course documents, so we have video links. I try to do as much of the lectures as I can in video and record them so you guys can go back in and get to them. But I also have other video links that are specific to certain items. So your homework assignment, one of them, doing the FTP, installing it, playing with Ubuntu server, there's actually a video link taking you step by step how to do that. Now, it probably will take you a little bit longer than my video to go through that, but those pieces are in there. So we try to get a lot of those in there. So if you haven't seen these and haven't looked at them, and why I'm mentioning this is I kept getting questions about several assignments. So Wireshark FTP. So this one here, FTP on the Ubuntu server for this week. When I went in and I looked at the views, because I can get a total number of views. I don't get who viewed it, obviously. But what struck me is I have 60 plus students in this class alone. I created this last year, so there were another 60 last year. There were only 49 views on it. So I know some of this material is a little tougher, and this one's one that probably is not an easy assignment to do. It's new. Working with the command line is not something most of you have done before. So it is a new subject. So I put these in there so hopefully you can take advantage of that. Now my other fear, because I broke it into these 2-week segments, is people are waiting until the last minute to do this. And there really are 2 weeks worth of material in there. So if you wait until Friday or Sunday at 9 o'clock, it's going to be hard to get through some of these assignments. This one, for example, I think I did the video in 12 minutes or something. But I've done this before. This is not new to me, so it's going to take you longer to do it. But it really does step you through piece by piece on that. So there are a few, the other piece I will mention, there are a few people that have 32-bit machines only. So they've got an older machine, they can't run a 64-bit operating system. If that is the case, this assignment can be done using the Ubuntu desktop version, because underneath that Ubuntu desktop version is really the same thing, the same code, and you can run a terminal window in Ubuntu desktop. I'd prefer you do it in the server version, just kind of get you that idea of what a command line looks like and how the world operates then again on that server side. But it's a tool that I have in there. So make sure if you don't or you haven't looked at those, that there's a lot of those pieces in there. So the other thing, and if I loaded it in the right spot, go backward one, go back. So down at the very bottom here, and you might just open this on your own computer, and you can even open it outside of Blackboard, which will give you a little more room to do it. So this is actually some real-world plans, so don't run out and reproduce any of them. This is off of a hospital project from 2009. So it's a few years ago, but the technology piece is still pretty solid in terms of what we're looking at. So because these plans are actually designed to be 3 foot by 5 foot and very big, we have to modify them and scale around a little bit here so you can see them. And I'm going to rotate this. And depending on whether you're in Adobe Reader or you're just in this, you can rotate it. So first plan, if I look through it, really has things like mounting height. So we go into great detail about the mounting heights of different pieces. Now some of these obviously are not just technology, but it shows you those typical heights. So we even get to the point of saying how far off the wall are data jacks, how far off the wall are electrical jacks. And so some of these terms that you've seen are starting to probably pop up. If I look at my symbols, so now you go, oh, a 4-post floor rack. hospital cross connect, horizontal, ground bars. All these different things are hopefully starting to show up. And you can navigate around by scrolling left and right, because obviously you're not going to get a lot if you don't blow this up a little bit. So this map also shows then which plan has what items in it. Things like grounding systems become very important. So I do not have the entire plans. I just have the technology sheets that we can take a look at. So if you're curious, this is what the outside of the hospital looks like. So there are wings with patient rooms, and those wings are driven oddly, and you'll see this kind of design in a lot of hospitals, by federal requirements that a hospital room has to have an outside window. If you didn't know that, now you do. So patient wings are over here. So emergency room entrance kind of over here is where we're at. So this hospital is already currently right now being redesigned and added to. So it's a fairly large facility for a small town. This one was about 65,000 square feet. A couple of other things you'll notice in this drawing, these things going through the hallway right here. And I know if you're online you're not going to see that, but in the middle of these hallways there are, look like lines with little W's in it every once in a while. Those are ladder racking. That means in the center of that hallway up above the ceiling tiles is a grate that we can put cables on everywhere we go. And so what you're looking up here to your upper left is, that is the patient area for like the doctor's office, for example, and we show those going around. That area is completely changed now, and they've added to it in addition to the surgery and some other areas. So you'll see that those run through all these hallways. The other thing you'll see is a kind of a black solid dotted line. That's a firewall. So in other words, it's a concrete block wall you have to work through so the entire hospital doesn't burn in one location. And so that hospital continues down. This off to the left, there's the dock, there's the mechanical room, so things like boilers. Off to the right-hand side of this image, where those big circles are, that's actually the operating suites, the 2 operating suites they have in this hospital. They are now adding on to this, and there's going to be 4, but right now there's 2 operating suites. And again, that cabling comes down in a ladder rack through the hallway, and you can get to it that way. So it's kind of the overview of a hospital, shows you some of the details about what it looks like. And if in the middle of this sheet right here, there's this little area here with got a little MC, and if you can see it there, that's actually the main server closet in the hospital. What you don't see is, immediately after it was built, and we'd already told the architects, that's not enough room. That server closet now occupies most of that entire square, that corner there, because they added so many items to it. So that was the original plan. Obviously, these things change quite a bit. And you can even scroll down a little further to the next page, and the next page shows a couple of additional buildings that are also part of that campus. So this building is connected with a walkway, and that has a lot of their finance services. Building costs often dictate why we do that. So standard office space is much cheaper to build, and that's basically a metal building, kind of like the AWAC Center, but it has offices in it, and then the other one is a garage. And they're not to scale as the distance, and so we had to provide services to all of those particular areas. So you can actually see this hallway running down up here on the bottom right. So there's a hallway that connects the previous sheet to this one, and then there's quite a bit of distance between these two. There's about 50 to 60 feet, and so we have to get into that building also. And there is no connecting structure. It is completely separate. So, brief overview of what you're looking at. So, what we also did was then, is we scaled out some of the typical rooms. So some of the rooms that had additional equipment, so all of these that have a ladder rack in them, that ladder rack really does look like a ladder. It's in the ceiling, or on the ceiling a couple feet down, and all our cabling coming into those rooms can then distribute around it. So in this particular case, there's actually 3 rooms with ladder racking in it that hold. So this is the main server closet and 2 auxiliary closets we used. And then the other ones are rooms that we jump into, those outside exterior buildings that you looked at. So a couple of pieces there, so you kind of some room layouts. We also show then a typical of like the racks, what the equipment is. So all of these things get into those drawings. That's where we start looking at what's in all of these different buildings. We even go to the detail of, hey, we specified that it's 568B connections. We specified how the grounding connections are, because one of the big issues we have in those, especially with multiple buildings, grounding becomes important. I can have electrical issues, I can have communications issues, I can quite frankly cause a fire and other issues. So grounding details become very, very important. So we actually specify in those drawings when you hire an engineering company to look at that. So here's all about the grounding details. Here's the ladder rack and then the power coming down on it. Even including like the door closures, exterior cameras, we have details for all different kinds of those pieces in here in our drawing. So in this particular building, we used fiber that connected the 3 different buildings, or the 3 different data closets and the 3 buildings together. So that fiber has a conceptual drawing of how it's going to be provided. So notice they show that link, and they're showing that we're using fiber, and it'll tell about which type's in. So we're using multi-mode fiber in this case, and it'll say, well, we're using C specifications, RJ45 to blah, blah, blah. So they're very detailed. And these are the kinds of plans you draw up, and then you get bids on when you're done. So we also had voice because we had phones, so you'll see similar diagrams. Technology tends to include television, so here's a television rough overview of the television cabling system. So all of these pieces land in there. Security systems, paging, cameras. We go to the details of even describing and creating a plan for how the cable outlets and the jacks are going to look like in different rooms and have typicals, because we want everything to be consistent. We want to be able to bid this job, send it out to a contractor and say, okay, we need all those pieces. So this is a list of all the receptacles. So if I scale out that plan, all of these pieces are what's on that giant plan, and so you can strip it out for content and for detail. So I can take all this detail, scroll. And if I go back then to the building plan, keep going up. Now I have all the details. I can actually enlarge this. I want to zoom, which is on. So I'm going to make this a lot bigger. And obviously, like I said, this is generally printed on 3x5 sheets. So now we can see an individual office. So this is a business office. And you can start to see that, for example, here we have a 2-position data jack. Here we have a TV mount. So in other words, that we have a cable connection. And here we have a data drop by it. A data drop in the ceiling, projectors. So by taking this, we create this entire document. We've created this ladder racking that we can run around. We take these, we create them, we hand them off to contractors to bid this job. So depending on which contractor, the contractors in this case stripped out the details and said, how many cable feet do we need, those kinds of details. We bid this out. So remember, this is in 2009, so a few years ago. This particular job, we had bids that ranged anywhere from $150,000 to a little over $1 million for the same set of prints. It's a big difference, isn't it? So it came down to different types of cabling, brands of cabling. Did they use US-made jacks? Did they use Chinese-made jacks? So they were very specific in their bids. The bid that after talking to various contractors we actually took was for about $259,000, I think, for this job. And that's one small hospital. That's just that was the telecom, that was the data, and the fiber for this particular building. That did not include any of the equipment in the building. That was just the cabling in the building. So, kind of a big project. Again, $2,009. With inflation, it'd be a little more. Obviously, although the price of some of the things have significantly dropped. For a reference, this job took 140,000 feet of Cat 6 cabling. Like those little green cables that you guys got to cut up. We actually put 140,000 plus foot of cabling in this building and about 10,000 foot of fiber. So now they've added significantly to that. And some of these rooms, so when you start adding them up, and now if I can navigate to it, if I can remember my way around this particular location. And probably on the next sheet up. All right, hang on. So the next sheet up, operating room. So if I actually look at the data coming in, so this data closet here had data coming in this way and that way, two different feeds. There are over 900 cables coming into that one room alone. And again, like I said, now, fairly quickly within the first year, that data closet now occupies out to here and is being expanded even right now as we speak. So typical. So there's also HVAC plans for this building. But that's what a contractor would look at to build. That's what you might get tasked with is you have a small facility. Now, 65,000 square feet isn't a really small building, but it's certainly within the range of most communities. This is in a town of 4,000 people. So if you get involved in those tasks, this is the kind of thing you might see. And so how do I know when I get those bids back from those contractors which one's the best? Do I just take the lowest bid? Do I take the highest bid thinking they must know something the other ones don't? And so you really need to be able to pick apart those bids and take a look at them and see what those are responsible for, what they are. But some of the prices have changed dramatically. So one of the things, so these are the recovery rooms for the surgery suites. And each one of them has a TV in it. And you've all seen a hospital, you see a TV, and you've probably bought a TV for going to college. In 2009, when we did this, those were 32-inch TVs we put in. Now what can I get a 32-inch TV for? Cheap, couple $100 at the most even. We paid almost $500 a piece for them then. And 32-inch TVs were fairly big. It just shows how quickly technology is changing. But the other piece, so can I keep that price in mind? A 32-inch TV, back then $500, a 40-inch would be about $1,000 or so. Now you can get a 40 for a couple $100 in some cases. So in the surgery suites, and I don't think it will easily show it, but if I look at those surgery suites, so you guys have kind of an idea how the surgery, they got the big central arm in them. And these arms have televisions on them that they use that the scopes and everything connect to. So they had an orthopedist that wanted to come in and do orthopedic surgeries in there. And they wanted a 40-inch medical-grade monitor to hook up to those scopes. You guys have any idea what a 40-inch medical-grade monitor in 2009, 2010 cost? Take a wild guess. Really close, $22,000. So I looked the other day, because I was just curious, because I figured I would talk about this. So today, that same medical-grade monitor is a bargain at a mere $8,000, or one very similar to it. Can I buy a 40-inch TV for less than $8,000? Why would I pay that much more for something that's going to be used in a surgery suite? What advantage do I gain? Well, they color match it so that the colors on this computer and the screen and everything are all matched together. So that way it's not light pink on one, bright pink on another. And so there is some tools that way. It's sealed so that they can sterilize it. But quite frankly, I think there's some profit in there at that $8,000 mark. So it's an interesting world when you look at some of those. But that's what the typical data plan. So offices would look very similar. And here, notice we have data drops, data drops, data drops. One thing I will say, if you ever get involved in this position, kind of a common cost item is you might say, $100 a drop. It's much cheaper to put them in now, before they put up things like drywall, before they do ceilings, than it is to come back and have to add data to those positions, because it will greatly affect that. So the other piece that you don't see in here, unless you look really, really carefully, are there are data drops for wireless. And so there's one right up there. The wireless system for this, so if you buy a wireless router for your house, and we're going to talk about wireless in the next couple of weeks, but if you buy a wireless router for your house and it's got little antennas or two, at the most you're going to spend a couple $100 if you go to Best Buy and buy some Nighthawk gaming router. But the wireless access points we use for industrial purposes are significantly higher. So the Arubas that you see out in the hallway in this building, and in this case we used a company called Ruckus, easily $700 to $1,500 for an access point of individually. So it's a different cost level and you get some different performance features than you would at home. So I just wanted you guys to see what this kind of details would look like. So you're welcome to look at that drawing and take a gander at it. So the other thing I will point out that the engineers who were hired to design this screwed up. So I said that you can only go 330 feet, 100 meters roughly, on Cat 5. Well, there's a hallway in this building that we were originally going to be able to run cables across. And the architect decided, you know what, we need to make that what's called a clear story. So they opened it all the way to the roof with windows in it, essentially, making this great lighted feature. Well, guess what? It made the data runs well past 300 feet, so we had to change some of the plans on the fly and get a contractor to do a change order for it. And so that was kind of an exciting thing to do. So if you haven't been in course documents, this is kind of where I lump and throw all different kinds of information in here. So course documents has videos. There's a couple of other ones that are kind of interesting. Here's using the command line FTP. And this has not been duplicated in the last couple of years. I keep hoping that some experimenter will do this. This was a map of the entire internet as of this point in time. Now, by map of the internet, it's major internet service providers. And when you look at it, you go, holy cow, I don't even know what I'm looking at. But when we actually scale that in, and it probably won't scale inside of this browser window. Come back. If I can find my... So it's not a geographic map. It's a connection map. And what it's showing you is those interconnections. So here we have, I just happen to scroll into here. You have Sprint Link, you have different ones connections. So this really is kind of an interesting thing. So this one showed 135,000 links. That was in 2006. Imagine what this would look like now. Some of the connections would change, but so far I have not found anybody willing to do that. We certainly don't have the resources here to do it. But it was an interesting project to map out the internet. And so you can see which companies at that point own significant ones. So I think it would be really great if we could come up with a current map and actually look at it in the same type of scenario. All right, so most of you have went through and done SpiceWorks already for the discussion board, I hope. SpiceWorks is a great tool. If you do that inside of a virtual environment, which is one of the ways I recommend doing it, and if you have a Mac, that's the only way you're going to be able to do it, the only devices you're going to be able to see are those devices inside of that virtual environment on that same IPs. So if you run it, one thing to try might be to fire up Windows 10, fire up Ubuntu, the desktop version, and look at them. You can fire up multiple editions of the same one even, and you can see those then start to populate and start looking at it. If you put it on a desktop computer, a standalone version, then you'll see everything in your network, and most of you are only going to see a few devices. But make sure you have went through and done that. SpiceWorks is really a great tool. So I will give you a case of where I actually have just used it this week. So I give some free advice to a utility that one of the problems that has happened is there is a really great company out there that their software, which was designed to remove malware, got infected. So if you haven't seen anything about that, it's a company called CC Cleaner. Great tool, have used it for years, except that that tool itself to get rid of malware and clean up your computer got infected. So I used Spiceworks and its scanning feature and installed it at a small utility, electric utility, because they were concerned that that was out there. Because they started getting bulletins from various agencies saying, make sure this isn't on your system. And I said, here, let me show you a tool you can use, and you can monitor what things are on your network, what things are on every computer in your particular destination. I think they have about 8, 10 machines. So could they have went to every machine and scanned for it individually? Yes. But this gives them kind of a control panel and that then they can log into and go, yep, I can see that, Sue has installed a piece of software. I can see that Mike has uninstalled the antivirus again and we have to go yell at him. So it gives you a really quick way you can do that. And there's several tools inside of Spiceworks now. And again, that discussion board threads are really a great thing inside of that community. So now that you've created an account in there, you can go into those threads at any time and look for anything. So I'm going to give you the lab connections reminder. I went through the other day and I think I emailed everybody who has not gotten a lab connections account. So what I was trying to do is compare the roster in lab connections and the roster in there. One of the problems with that is some people did odd things, including using other emails. They put their names in, not last name, first name. So if you got an email saying, hey, get a lab connection account, and you actually have one and I missed it, my apologies. If you haven't gotten lab connection, get it. It's 30% of your grade. You can do it multiple times. You can do it until you have 100% on every one of those assignments. So everybody at the end of this class should have at least a 30%. The flip side of that is, even if you had 100% on everything else and you decided not to do it, it would certainly affect your grade there. So the first weeks are a little stale. They get a little more exciting as we go through there. So let me open this. So we stopped and we talked about fiber a little bit. And yes, I want to authenticate. Cancel. So, a couple of pieces really quickly. So this, and I know that people online can't see it, but I'm holding it in my hand. This is a mini GBIC or an SFP. So this actually is a transmitter, just like what they're showing you there. It slides into, and if you want to look at it in the back, we can actually plop this into our switch back there. This is a transmitter and a receiver all in one. Really small device, and they've gotten where they're fairly affordable. So a 1 gig module like this I can pick up at the fiber store for 25 to 50 bucks all day long. So very affordable. Even from the manufacturers, so if I buy an HP switch and I say, I want to buy some of these, they're a couple $100. But they're very affordable. The 10 gig models, I can actually get them in some cases for $100 or less for a 10 gigabyte module. So our communications, our speed is going up and price is going down. And so these are a really handy way that we can connect switches together, can connect our networks together. And so that's actually what it looks like. That's the size of this guy there. So I know you guys have probably seen it, but it's kind of a handy thing. We now can buy switches that are nothing more than these SFP sockets in 10 or 20 or 30 sets of them. So we can do that. So you can test those SFPs really quickly. They make a loop back. So all this does is allow me to plug into it and essentially determine that we really are making a loop. Now, this is an unsophisticated $20 tool. It doesn't tell me anything other than, hey, I've got basic connectivity. But it's a handy tool in a lot of server closets and things. We just hang them in there because it gives us a really quick way to do it. So all of those fiber standards, so they work the same way we do the twisted pair cables, except we use F or LX, and you'll see that we don't have a T anywhere in there, and that maybe is the easiest way to explain it. So, the original standards, nobody uses 100 base fiber anymore. No reason to. The other standards are coming out so fast. So, what you actually see right there in front of you is, that I'm passing around, is a 1000 base SX. So there are a couple different models. There's LX and SX. Both of them are great. They'll do a gig each direction, bidirectionally. We have the details. The reality is what we're looking for is mostly distance. And both of those are good for at least 500 meters, maybe more. Remember, we're limited to 100 meters on our twisted pair. Well, fiber now, we're getting some models we can go significantly further distances. So, the first of the 10 gig models, so there are models that are 1000 gigabit or 1000 megabits or a gigabit Ethernet that will go significantly further. There are ones that will go out to 10,000 feet or more. But we move into the 10 gigs, and that's really where the differences start to go. So the 10 gig, those ones I said I can get for $100, they're really not going to hit 10,000. I mean, they're not going to hit a giant distance. And so that's one of the differences. So they're SRs or SWs, and they will do a short distance, so 300 to 500 meters. It does depend on the type of fiber, how much power loss you have, that they're matched properly. But most of those are multi-mode fiber. It's great around our campus. Works really, really well. The distance works fine. But we get further distances. We want to go from town to town. Now, we have to go to single-mode fiber. And notice that we go, these ERs and EWs, all of a sudden we're out to 40,000 meters plus. 40,000 meters. So we don't have to repeat nearly as often. So that's 40 kilometers or about 25 miles. There are now models that we can run 50 to 70 miles on really good glass that has the connection soldered with very low loss. And so we try to push those out as far as possible. So level 3, for example, between Omaha and Kansas City. Omaha and Kansas City is about 150 miles, roughly, the way that it traverses. There is one, what they call a regen center between the two of them. They don't have to do that except once. So as technology moves, those distances get greater and greater and greater. So what do we need to deal with noise? So part of the issue, we know we have power loss. So as the signal goes, the further it goes, the weaker it gets. And you see that with a flashlight. You see that with your radio. The further it goes, the less signal we have. So one of the things we have to do is minimize what kind of transmission flaws we can have. And so the most common thing you're going to see, especially on twisted pair, is some kind of radio frequency interference. So maybe it's a bad light fixture. But what it really does is those cables are sitting next to each other, and we have this crosstalk from one to the other, and this cable sending a signal, and this one picks it up. So that's that idea of crosstalk. So we want to minimize that. And one of the things we do to minimize that is we don't run cables next to electrical cables, for example. So we want to put our data cables at right angles to power cables as much as possible. So anytime we have a signal from one to the other, we call it crosstalk. Whether it's alien, in other words, it's a different cable, or on our own cable. They make a big deal about next and far end. So near end and far end. Well, that really is relative to where you're looking at it. So if I'm looking at this end of the cable, it's near end. Far end then would be at the other end of the cable if I switch positions. So there's no definitive. It's always the north cable is near end. It happens to be your relative positioning. So The other thing, of course, is we know that the signal gets weaker the further it goes. So your car headlights only go a short distance and then they start to fade out. Well, the same thing with anything we send. We have to have some way to deal with that signal loss. And there's two ways we can do it. So we can put an amplifier in. So just like in that car amplifier, now you're making your speakers louder. But if that signal is really noisy off an old noisy FM channel, you're also amplifying that noise. So an amplifier is good, but it also boosts the noise that's in it. And then we have a digital repeater. So an amplifier raises the signal level, but it also amplifies the noise that's in it. So we have limited times we can amplify something before it becomes unusable. A repeater, though, or what we call it in the fiber optic world, a regenerator, we get the signal, so here comes our signal. Even though it's got noise in it, we can still read that as a 0 and this is a 1. And it comes into this repeater and it recreates that signal completely. Now there's a downside to that. So the downside to that is if I regenerate that signal, it takes a little bit of computer processing. And so I add what's called latency, or how long it takes that signal to transmit. Whereas if I amplify it, it doesn't slow that signal down or any latency to it. But it does allow that noise. So we have to deal with that latency issue. So latency is caused by two things. The cable length, how long a run we have. So obviously from here to Germany is significantly longer than from here to our administration building. And any devices in between, because each device in between adds some latency or length of time for it to work. So there are businesses that worry about that. So those high-frequency traders on Wall Street, they worry about how can I minimize my latency and get my trades in 1/100th of a millisecond faster than what we're doing. We can measure that, how long it takes to send our data. We look at that as something called RTT, round trip time. And so when we did a ping, you actually saw that. So there's a couple of other things that can happen. So on fiber, there's a couple of different core sizes. And so we have to match the transceiver with the core size. So the one that's going around is matched for a 50 micron core. That transceiver, if I plug in a 62.5 millimeter, it'll work, but it's mismatched. It doesn't run very well. So picture Usain Bolt, but wearing shoes that are too small. Is he going to be able to run as fast? No. So that you need the core of that fiber and your transceivers to match. You may also have wavelength mismatch. In other words, I have fiber that's designed for an 8 millimeter wavelength, and we put it over the wrong cable. So that typically are the two that we see often. Dirty connectors, so where they plug in, you can actually get dirt on those. And we've seen that in some industrial applications. Usually these things are in a fairly robust container, but those happen. So it's usually a setup error or configuration error. And you'd think that the big contractors don't screw this up. But again, I told you about that job that down in Falls City, and quite frankly, the contractor screwed up putting in the fiber in there. And the transceivers and the things that we had specified, because on top of that drawing, we had a whole request of items and a list of what was needed. And we already had equipment bought, and the fiber that they brought in and our transceivers were not a match. We didn't take into account that we were in such a hurry to get it open, that we built this hospital, we did that, hooked it in, and it sort of worked, but we had some odd data connection issues, and we blamed all kinds of other things, because quite frankly, we went live about the time the hospital did. There was not a lot of time for prep, and what it turns out was we had a mismatch between the wave size and the fiber size, and so we had to end up replacing a whole bunch of transceivers to get them to work correctly. So we're actually going to be live in here and play with a couple of these tools. So some of these tools you may have seen phone companies use, and I'm going to bring in one so you can see. So we create a tone generator and we locate cables this way. So if you've been around when they're putting in phone installs, that's a pretty common thing for an electrical service. You might also see them called a fox and hound. Multimeter is kind of a general purpose, so we can measure electrical voltage, resistance. We don't use those as much in networking. We kind of plug it in and we say, okay, does that work? But what we do use quite a bit are cable continuity testers. And so you'll see some of those, and we have some all the way from, I'll bring in a couple of mine, and then we have some in the back that are some $8 models. And so we can actually test the cable then to see if both ends work. So very important when we build something like this, we actually go through, like at that hospital, and you will certify each cable. Now, a certifier then can run $10,000 to actually do all of the testing for it, but we can get about 90% of the way then with just a quick pass. So you may see something and it looks like this. That is a really quick cable tester. And again, we've got some in the back that you can see that work very, very similarly. All it really does is check each line to see if it's connected right. It doesn't measure if it's connected well, but it does connect to see if it is connected at all. Let me see if I can grab one really quickly, if one has not gotten moved. So these are what we're looking at about the $10 mark, these kinds of guys. So you can open it up and play with it. So you plug a network cable into each end. It's got a set of lights, and it says, hey, up, I made a connection. So they're kind of handy. They're a really quick test to see if we are connected. We also use them to plug in if we don't know which cable line is connected where. You can use them then to try to identify where a cable is connected. So that's kind of a really quick measure. But then you have cable testers that have more features or more pieces to them, and I'll show you some of those. So they go all the way to the extent of some of them will have printers, some of them stored on USB cards, and you can print out. This is cable 137. Here are its characteristics. So they will do everything from measure power loss, near and far end crosstalk, resistances. So sometimes these are really a lifesaver. You may end up with a cable that will pass on that little guy right there for $8. But it's very marginal. Maybe it's slightly too long or some other reason. And so these cable performance testers or certifiers will give you that information. And they're, like I said, they're anywhere from $2,000 to $10,000 depending on what you want to do. We also have a tool called a TDR, Time or Domain Reflectometer. So this actually sends a signal, and as it bounces back, it reads that symbol or that signal, and it can tell you if it's connected right. At its basic level, it can tell you how long that cable is, and it can check all the way along through it. We also have one called OTDRs. And when we do fiber, we look at OTDRs. These actually measure everything from the fiber length. I can determine where every splice is at from that light that bounces back. I can find breaks. I can find bins that are out of spec. These guys are expensive. About the cheapest decent OTDR is about $40,000 to $50,000. The college has not let me buy one of those or any of the other equipment yet. I'd like to. I keep mentioning it, and I get told that no. So they're coming down, and they'll soon get probably to the point where we can afford one. But what it really does is it measures that cable. So because fiber optic cable is traditionally fairly pricey, so the outside plant cable that you see when they're putting in fiber for like Zoyo, which just went through, or Quest, or any of the big players, you're talking $8 to $10 a foot for that cable. They will actually use OTDRs and measure it at each reel of cable to make sure that cable and get its characteristics. And then as they splice them together, then they'll do one at the end to make sure that it meets all of the specifications. So I wish we had an OTDR here, but unfortunately we don't quite have that yet. So these are some cable testing tools. So the left that's an older model of a Fluke. That guy's about $2,000 to $3,000 depending on which pieces you add in. This one's an optical power meter. It doesn't do the whole OTDR, but what it does is send a light pulse down, and you can measure how much power gets lost. So kind of a cheap little tool that you can use. So it will tell, hey, did I get that? What kind of power loss am I using? But it can change. A lot of different things can change to make those not necessarily as accurate. So I thought I had a link to it, but I apparently don't. So Win and OTDR. Well, here is a really cheap model, and these don't work very well. I will tell you that. That's an OTDR, a little portable model. There's not even a screen resolution to do much, but it looks really neat. But we could plug it into our fiber, and we could look at it, and you can see. So most of the models, when I do that, you're not even going to see a price for. So here's one that's at $14,000, probably a little more useful. But as you get more competition, I will say one of the interesting things, the name brand units have knockoffs and clones being distributed, and so you have to be careful of what you actually purchase in there. So just because it says it does all these features, it may do it for 30 days, and unfortunately, it may die. So there are a lot of pieces that we look at in there. So if you're curious about the right one. Someday I'm going to get a monitor I can actually read in here. So, no, not the right one. Has some interesting pieces for some glowing pieces, but I'll put the link in to the place I have bought a lot of fiber optic stuff in there. I thought I had put it in there. I apparently put it in one of the child classes, which I have done a couple of times in here. All right, so this Sunday, we have a couple of things due. So make sure you've done the SpiceWorks. You'll need to have installed the server, the FTP server inside of Ubuntu. So that is actually in your assignment link. We are probably going to change a little bit of next week or the next chunk of assignments. And part of that is there's a conference that I will be at for about half of that time. So we'll probably change up and pull out something. So I know you're all going to work ahead, but I will try to make a decision on which piece I'm going to pull out tomorrow. Sometime in there. If not by tomorrow, sometime in a meeting. Tomorrow I'm actually at a conference, so I'll be doing a little work on the laptop. So the next week's assignments are probably going to be something yanked out of there if anybody doesn't object. I'm waiting for the objections. Still waiting for the objections. All right, so we've tried a couple of different tools in here. So